Welcome to Electronic Geek. In this video, we will see about a basic memory element that is latch. We will discuss about SR latch which will be implemented with the help of NOR gates, and we will also see about pull down resistors. So let's get started. A circuit which is capable of storing data is called as a storage element or a memory element. There are two types of storage element. First is the latches, the other is flip-flops. So latches are devices that operate with signal level, meaning the output will vary as per the input signal level. Okay. So in this video, we are going to talk about SR latch. This SR latch can be implemented with the help of NOR gates as well as NAND. In this one, we are going to implement it with NOR gates. So the SR NOR latch is designed with two cross-coupled NOR gates. The inputs are S and R. The outputs are Q and Q bar. We will implement this SR NOR latch and we will see the results. So here is the circuit for SR NOR latch. As I had told that in SR NOR latch, two cross-coupled NOR gates are used and these are the two inputs R and S. Remember in an SR NOR latch, the order, okay, the first input is R, the next is S. This is important, okay. You have to keep in mind that the first one is R, the next is S, and even in the output, this first is Q, the other is the Q bar. And in this circuit, you can see that for this NOR gate, one input is S, while the other input is the output of first NOR gate. Okay, same goes for this first NOR gate. First input is R, and the second input is the output of second NOR gate. Over here, I had to demonstrate about pull down resistors, and that is the reason I have used this SPST switch, that is single pole single throw switch. So this plus 5 volt is connected to these two signals via an SPST switch. So coming to the working of this SR NOR latch, this is the truth table for NOR gate. In this truth table, you can clearly see when either of the one inputs is high, the output is going to be 0. Now we will see the working and we will see how this circuit is capable of storing data. So we will take the first case, that is when R is 0, S is 1. Now we just saw that when either of the inputs, okay, is high, the output is always low. So when this S is 1, okay, output of this NOR gate is definitely going to be 0. And this output is connected to this input. And R is also 0 and this is also 0, which means this output will be 1, meaning Q is 1 and Q bar is 0. Now when this is the case, that when Q is 1 and Q bar is 0, we call that the latch is in set mode. Now for the case when R is 0 and S is 0, now remember in the previous state this input was 1, okay. So now when S is 0, this is 1, output is going to be 0. As it is connected to this, the output will be 1. So when R and S both are 0, you saw that the result was same as the previous one. It means that it has stored the data. The case when R was 0, S was 1, we had Q equal to 1, Q bar equal to 0. And for the case when R was 0, S is 0, we saw that the output was same. It didn't change, which means that it has stored that data. Okay, now coming to the case when R is 1, S is 0. Now when R is 1, the output is obviously going to be 0. Okay, so Q is 0 and S is 0. So 0 and 0, we will be having 1. So Q is 0, Q bar is 1. Now for the case when R is 1, S is 1. Now understand this part properly. When R is 1, the output is going to be 0 at any cost. We have seen the NOR truth table. And when S is 1, the output has to be 0. We are having Q as 0 and Q bar as 0. Now how is Q equal to Q complement? This means that this stage is a forbidden stage, meaning you should never implement it. Okay, we should never implement R equal to 1 and S equal to 1 because the outputs are completely wrong. So we have seen that for the case when R and S both are 0, the last state of Q and Q bar is retained. So let's simulate this circuit and check our results. Now R is 0, okay, the circuit is open, and let's select S as 1, okay. Now for the case when R is 0 and S as 1, okay, ideally Q bar should be 0, Q should be 1, but it didn't happen like this. Why? Let's try and debug this issue. Okay, we'll stop the simulation. We will use this voltage probe. Okay, we will put here, same goes for here. Let's simulate the circuit to check the voltage over here. See, over here the switch is closed. You can see 4.99 volts. Over here, the switch is open. Still, a voltage of 4.03 is appearing to this input of NOR gate. How come? This wire isn't connected. It's in floating condition. Okay. So, in order to debug this issue, we have to use pull down resistors. Pull down resistors are resistors that connect the wire to ground when the switch is open. So a pull down resistor has to be used to in order to resolve this issue. Every logic gate has a specific range of voltages for which the input signal will be considered as low or it will be considered as high. So in this 74LS02, voltage from 0 to zero point 0.8 is considered as logic low, okay, or logic 0, whereas voltage level from 2 to 5 are considered as logic 1, okay. So there is no specification for the range of voltages from 0.9 to 1.9. So under this situation, we have to use a pull down resistor in order to debug this issue. We will see the datasheet for this 74LS02. Over here, you can see that low level input voltage is 0.8 volts, and over here you can see low level input current is 0.40 milliamps, which is almost 400 microamps. Okay, so the value of this pull down resistor is connected by this formula, that is the low level input voltage divided by low level input current. Okay, so 0.8 divided by 400 microamps gives you 2000 ohms. Okay, which means we will have to connect a resistor of 2k over here. So we'll stop this simulation over here, and we'll take the resistor, we'll place it over here. Same goes for over here, and we'll connect a ground like this. We'll change the sorry we'll change the value of this resistor from 10k to 2k. Same for this one. Let's check our answer. I will open this one. Now we will simulate the circuit. Okay, so for the first case, okay, we'll keep R as 0 and S as 1. So by this logic, Q bar should be 0, Q should be 1. Let's check it out. See, we are having Q as 1, Q bar as 0. Now, when R and S both are 0, I should retain this state of Q and Q bar. Let's check it out. See, the state has been retained. Now again, R as 1 and S as 0. So Q bar should be 1 and Q should be 0. See, now if I open this R and give it 0, this state will retain. If I keep both as 1, R as 1, S as 1, it is a forbidden state. None of the LEDs will glow. So can change the state. Whenever I take R and R as 0 and S as also 0, the previous state of Q and Q bar is retained. Thus we can say that this SR NOR latch is able to store this data in it. So this is it for this video. Thank you for being till here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubt, suggestion or feedback, do let me know in the comment section. Thank you for being till here. Thank you so much.